Jason?
Okay.
Alright, so what we're going to do today is look at another set of functions. So back in chapter 3, we had these functions that we were looking at up here before, from earlier. So we talked about all of those different kinds of functions. If you remember in chapter 3, we had, back in the day, the square root functions that started at the origin and went up like that. Remember those? They were all started with the base or the parent function, square root of x. And we had the absolute value functions that we just looked at in our warm-up today that all started with the parent function, the absolute value of x. And we had the quadratic functions that started with an x squared. Today we're just going to look at another group or family of functions that are called the rational functions. And the rational functions are any functions that have a number or a function over x. So you're going to have an x on the bottom of a fraction. So the rational functions are specifically defined, and I would not write this down if I was you, because you will never be tested on the definition of a rational function. But a rational function is any function that can be written as one function divided by another function. So you might have a constant on the top, like 1. 1 is a function. If we think about the line y equals 1, we would just go up to 1 and we draw a line. And it definitely passed the vertical line test because it only ever touches at one place. Over something that's going to have at least an x in it. So it says it's going to be something over another function where both p and q are polynomial expressions, some kind of a function essentially, and the denominator has to be degree of at least 1. Well, if you recall again back from chapter 3, we had functions that were like x to the third. That function would be degree, what? Who remembers? What? 3. So if it was x to the third, it was degree 3. So the degree and the exponent were the same number. So if something is degree 1, that just means that it has to be at least x to the first power on the bottom. So for anything to be a rational function, it's going to have an x on the bottom. It can have a variety of other things. But we're going to start with this as our parent function. And the rest of chapter 9, we're going to talk about these rational functions that start from the base function and the parent function, 1 over x. So just like when we were on chapter 3, we're going to start with a little bit of graphing. So if you would please snag your calculators out, if you have not yet. I want you to go into your y equals, and on your y equals we're just going to graph 1 divided by x. And this time instead of hitting graph, just because we've had a lot of other stuff in our calculators lately, I want you to hit zoom 6. So that we all start with the same basic function or spaces. If you see your function, it looks like it goes down this way, and then it comes up that way, and it comes down here, and it goes over here, but it never actually crosses or touches the x or the y axis. Can you see that on your graphs? The x and the y axis are lines then that graph gets really close to, but never touches. A line that a graph gets really close to, but never touches, like in this case, the y-axis and the x-axis, is called an asymptote line. And the asymptote is literally just a line that kind of directs the function. It gets real close to it, but it never touches it. So, if then, instead of graphing 1 over x, we want to graph 1 over x plus 1. If I added a plus 1 out here by itself, how do you think this graph is going to move? It's going to move It's
Left.
not, nope, it's just going to move up, down, left, or right. Which do you think?
Left hand.
How many people think up? You are all the right people. We'll look at it moving left and right in just a minute. Okay, so if I were to go back to my y equals, and instead of saying just 1 over x, go ahead and put it in parentheses this time so that we make sure that we don't confuse it. We have our 1 over x, and then at the end we're going to add 1. Just like with all of our other functions, our absolute value, etc., our whole graph is going to now move up 1. So instead of being down here, this graph moved up 1. So each one of these spaces moved up 1, up 1, up 1. These lines pretty much correspond once you get to one point. The same thing here, instead of being my base function, the whole thing shifts up 1. It's a little harder to see it in a rational than it is when it's the v. When it's a v, you got your v, and the v moves up 1. Yes, ma'am? Your calculator's not working? Can you just share with somebody at your table for right now, and then we'll fix it as soon as we're done with notes? Okay. So if a number on the outside moves it up or down, a number right next to my x is probably going to move it left and right. So if we were to, instead of putting our moving down line, go ahead and clear that second one out, and instead put in 1 divided by, and put your x minus 2 in parentheses if you would please. Otherwise sometimes your calculators think that minus 2 is on the outside. 1 divided by x minus 2. And just based on the fact that when I did that I put it in parentheses, what is that trying to tell you? It's going to move the opposite direction of what you think probably, right?
Yeah.
So instead, there's my base function, and my new function took my whole thing and it moved it to the right 2 units. Took my function over here and it moved it right 2 units. Now, if I scroll in, let's see if I can zoom in here a little bit. We're going to see what we can write with if it will come off for us. But if we took our original functions, which were these two, this one and this one, and that had a vertical asymptote of x equals 0, or horizontal, excuse me, and a vertical asymptote of y equals 0, and then we compare that to our new function that moved over to and to the right on both sides, so over 2. Now, if you're looking at that, it looks like there's some part of the graph that goes up like this. Do you see that part on your graph? No. Some of you might not have that. Okay? If you don't have that, you actually are probably happier right now because it looks like it's part of my picture, doesn't it? So if you have it, you're going, well, what the heck is that line there doing? That is a new copy. My calculator is currently programmed to show the vertical and the horizontal asymptotes. So here I have an asymptote that I'm getting close to, but I never actually touch. So this line right here is not part of my graph at all. It's literally that line that my green graph is getting closer to, but it's never really touching. The x equals 0 line never changed. So if I were to try to tell you what lines this was getting closest to, but not touching, these new red dashy lines, I could find those lines by looking at my graph or looking at my equation. And right now I tell you that I have an asymptote at x equals 0, this line right here, or y equals 0, excuse me, and I would have an asymptote at x equals 2, this line going up and down. So I have a line here at x equals 2 that I'm getting closer to, but I'm not touching, and a line here at y equals 0 that I'm getting closer to, but never touching. And I'll show you exactly how we find those on our graph in just a second. Another thing that we can do to our graph is change the scale factor. So just like we had that scale factor on our warm-up today, where we had the 3 on the bottom, if we put a number out front or a number next to the x on the bottom, it's just going to change the scale factor on our graph. So if you would go back to your y equals for a second, leave your first one, clear out your second one. I'm going to try to erase my green and red here for a minute. I know it's not going to come off all the way, but we'll see. And in that second line now, I want you to put 3 times, 3 parentheses, 1 divided by x. I know it's hard to see it up there. And then we're going to graph it again. My black line again is my original function. And then if you can see my new function, and you can probably see it better on yours because mine's a little bit off. You can see the new function here is a little bit flatter than the function before. Or fatter if you were thinking of the absolute value ones. And again, my function moved from being up here to down here. The graph itself hasn't moved. I'm still having the same asymptote lines. It's still not crossing x equals 0, y equals 0. But now instead of being as steep as it was before, now it's a little bit more flat. We can even have full equations on the top. If we have this whole equation on the top, really what we're looking at is moving it to the right one, and we have a new scale factor. So while I get the marker off my calculator, go ahead and try to put this one in your calculator and see what the difference is between the original and the new one. Make sure you have both sets of parentheses so it doesn't hang anything off on you. And when we graph, if I can find the graph here somewhere, 2x minus 5 over x minus 1, we start with our base function, still in that first quadrant. But our new function, it still looks the same, but mine is flipped over, and it's moved a little bit over, and definitely has moved up a little bit. So I've come up, and I flipped. So there's still a relationship between my 1 over x function and my new function. It's moved over, it's moved up, it's moved around, so we've got a few different things going on there. For the most part, tomorrow when we work on these problems, because we're doing review stuff today first, you're going to be asked to look at some of the functions. Recognize the parent function. Be able to remember that when we add a number on the outside, way out here, that's going to move it up or down. Positive numbers are going to move it up. Negative numbers are going to move it down. When we add numbers on the bottom right next to our x, they're going to move them left and right. If we add a number out front, it's going to change our scale factor. So the only other thing they might ask you to do is identify those asymptote lines, the lines that your graph is getting closer and closer and closer to but never touching. And we can both identify them by looking at the graph, and we can also identify them by looking at our function itself. So our asymptote lines, if you look at the very bottom of the page here, asymptote lines, again, are lines that the graph approaches but never actually reaches. It gets closer, 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 closer to, but it never actually gets there. So in this equation, if we were to graph this, we would find the asymptote lines by looking at first what number on the bottom is going to make the bottom of our fraction 0. So in this case, what we do is just set this bottom equal to 0, and we would just get x equals 0. And any number that we have hanging out here on the end. If we don't have a number out here on the end at all, then if you go back to the very first one, when there's not a number out here on the end, the asymptote is just at 0. So when there's not a number, we can just assume the 0 that's out here. When there is a number on the end, it's gonna move that asymptote up to positive 1.